how do you define a black hole?
It's just a region of space from which even light can't escape.
And by understanding what they are and knowing more about them, what do we then learn?
So Stephen Hawking, back in the 70s, published a paper. The initial one was called Black Hole Explosions, which is a great title for a paper. He found out that black holes, in his language, he said black holes ain't so black. Like, they glow in the sky, like coals in the sky, and they radiate. And so over time, they lose energy and mass and ultimately disappear over huge timescales. And that's so important that if you go into Westminster Abbey and look on the floor of Westminster Abbey, on Stephen's memorial stone, then you find his equation for the temperature of a black hole literally chiseled in stone on the floor of an abbey. So you might say, why? Why is it so important? This was the key. This was this Rosetta Stone idea in trying to understand what happens. What happens to the stuff that fell in? When you thought these things existed forever, which is pre-Hawking, then you think, well, it's okay. It gets locked up inside. It can never get out. We don't care. But the thing evaporates away. One day it will be gone. So then suddenly you have to be faced with this question, what happened to everything then? If I throw a book into a black hole, is it somehow possible in the far future, if you collect all this so-called Hawking radiation that comes off, is it possible to reconstruct the information in the book? And that's been a question, simple question, that's driven this tremendous amount of research for 50 years. And it was pretty much solved in 2019, actually, and 2020. The statement is everything comes out again, all the information comes out. So everything that fell in principle, in the far future, you could reconstruct the information of everything that fell in. It's an astonishing idea. The last thing I'll say is that before the Hawking papers and before this modern understanding, inside a black hole, just according to Einstein, sits the end of time, which is an astonishing thing to say because we can see them. We have a photograph of one of these things in the center of a galaxy. When you look at that photograph, you're looking at the end of time in space. So then you think, well, if things go to the end of time, how does everything get out again? Yeah. And that's the content of this tremendous work in theoretical physics. This work, studying black holes, it's one of those things that a certain kind of person says is useless, right? You say, why? Who cares? Right? It turns out that the techniques that are being developed and the understanding that's being gained from looking at these things has got a very strong crossover with building quantum computers. Quantum computers are in laboratories now. They have a tremendous potential to revolutionize our civilization. Incredibly powerful computing devices.